Hello everyone, today we will be talking about the different stages of life that a star goes through. I will be discussing each stage one by one until its inevitable death. The beginning. Stars originate in vast cold clouds of gas and dust, known as giant molecular clouds or nebulae. These regions, rich in hydrogen molecules, can span hundreds of light years and contain enough material to form thousands of stars. Disturbances such as shock waves from nearby supernova can trigger regions within the GMC, giant molecular cloud, to collapse under gravity, initiating star formation. Protostar, the forming star. As a region within the GMC collapses, it forms a protostar, a hot, dense core surrounded by a rotating disk of gas and dust. The protostar continues to accumulate material from its surroundings, increasing in mass and temperature. However, nuclear fusion has not yet commenced. Main sequence, the star's prime. Once the core temperature reaches approximately 10 million Kelvin, hydrogen fusion into helium begins, marking the star's entry into the main sequence. For a star like our Sun, this stable phase lasts about 10 billion years. Red giant, the expanding star. As hydrogen in the core is depleted, fusion slows and the core contracts under gravity. The outer layers expand and cool, transforming the star into a red giant. Hydrogen fusion continues in a shell around the inert helium core, causing the star to expand significantly. Final stages, the star's fate. As stars like our Sun exhaust their nuclear fuel, they expel their outer layers into space, creating a planetary nebula. This glowing shell of ionized gas is illuminated by the remaining hot core, showcasing intricate and colorful structures. White dwarf remnant. The exposed core becomes a white dwarf, a dense Earth-sized object composed primarily of carbon and oxygen. Supported by electron degeneracy pressure, white dwarfs no longer undergo fusion and gradually cool over billions of years, which at the end leaves a black dwarf. In massive stars, the core continues fusion up to iron, which cannot release energy through fusion. Once the iron core exceeds the Chandrasekhar limit, approximately 1.4 solar masses, it collapses under gravity, leading to a core collapse supernova. This explosive event disperses heavy elements into space and leaves behind a compact remnant. If the remaining core mass is between about 1.4 and 3 solar masses, it becomes a neutron star. These incredibly dense objects, about 20 kilometers in diameter, are composed almost entirely of neutrons and can rotate rapidly, emitting beams of radiation detectable as pulsars. In very massive stars, with cores exceeding approximately 3 solar masses, the collapse continues beyond the neutron star stage, forming a black hole. This region of space-time exhibits such strong gravitational effects that nothing, not even light, can escape from it. So this was it, the natural life cycle of suns in different sizes, although most stages cannot be reached yet, because it would take longer than the age of the observable universe. For example, the black dwarf. It's still fascinating to know that these heated giants will continue to live long after we are gone. Thank you for watching.